Hi everyone, welcome back to my channel. If you are new to my channel, please consider subscribing my channel and hit on the notification bell so that if I keep any videos, you'll be getting the notification. Okay, so as for today, we are going to discuss about what is verilog, scalar, and vector. Okay, how are we going to represent a scalar and vector in verilog? So, scalar is nothing but it is a single bit representation. That means, for example, let us consider if we are writing, okay, integer a. That means if you see here, you didn't give any width for this particular a, right? So, when you are not giving any width to that particular variable, then it is represented as a scalar. Okay. Now, for this same example, if I am taking like sum of a, okay, that means you are giving some width. Okay, that means when you are giving some width, then it is called as vector representation. Okay, so whenever you are not giving any width, by default every variable is scalar. Okay, so whenever you want to give some width to the particular variable, then that is called as vector representation. Okay, so see, verilog needs to represent individual bits. That means whenever there is an individual bit representation, then that is considered as a scalar. And if it is of multi-bit, that means multi-bit means if you are having giving some width of for that particular variable, then it is called as multi-bit, and that multi-bit representation is called as a vector. Okay, so in this representation here, this particular width is represented is having some syntax, and the syntax is as follows. See, MSB and LSB. Okay, so the rightmost bit is called is considered as LSB, and the leftmost bit is considered as MSB bit. Okay, so MSB down to LSB, we will call it as MSB down to LSB. So this is the syntax for vector representation. Data type. So here see, we have discussed about the data types in the previous sessions. If you are not watching that, first watch what are data types and then come to this particular session. Okay, so data type, that is integer is the data type, and then if you want to represent width, it will be represented as a width, and then the identifiers. Identifiers are nothing but the variables that you are naming. Okay, so this is how the scalar representation, sorry, vector representation is done. If you are not giving any of this, then it is considered as like wire a. So this is called scalar representation. Okay, so again, in this vector representation, it is like it is divided into two types. Okay, you can either represent it in two ways. Like if you are representing it in this way, like 7 down to 0, that means the MSB bit is A of 7 and LSB bit is A of 0. Okay, that means here when you are mentioning like 7 down to 0 a, that means 8 bits, 8 memory locations are allocated. If you see here, 7 down to 0, that means 8 memory locations. 1, so see here, 1, 2, 3, 4, 5, 6, 7, 8. So 8 memory locations are created. Okay, and the leftmost bit is A of 0 and the rightmost is A of 7. So in this way, if you are representing, then that is called as little endian process. And if you are mentioning it in this way, that is MSB is A of 0 and LSB is A of 7. That means MSB memory location is represented as A of 0 and LSB memory location is represented as A of 7. Then that is called as big endian process. Okay, let us see some examples here. Wire O underscore nor. Okay, that means here you didn't mention any width. Since you didn't mention it is any width, it is scalar. Now for this a, you are mentioning a width, so that is vector. What is the width that you are mentioning? 7 down to 0, that means 8 bit. Here if you see, 7 down to 0 means 8 bits memory locations are allocated. Okay, here you didn't mention any width, so it is single bit scalar. Here 31 down to 0, so 32 bit. Okay, in this way there are. And also when you are mentioning, when you are representing the width, it should be in the numerical representation. Like you need to give the memory allocation some numbers. Okay, you shouldn't give it like this. If you see this, this is called as illegal. Why? Because if you are giving it like this, my MSB, it is not any particular, then the system doesn't know what to allocate. Okay, then it will throw you error alert that it is an illegal representation of the vector. Okay, and this is about little endian and big endian, like these are how the memory locations are stored, right? So see, these are some of the examples for scalars. Okay, and these are some of the examples for vectors. So again in this scalars, as I already told you, sorry, in vectors, as I already told you, vectors are nothing but you are increasing the width of the particular variable so that it can allocate more memory locations. For example, if you see the example here, register reg, okay, 7 down to 0 address. So from this you can understand that it is of 8 bit. Okay, that means see, 1, 2, 3, 4, 5, 6, 7, 8. 8 memory locations are created. So in this 8 memory locations, for example, if you want to send some particular data in this 8 memory locations, but you don't want to send the data, entire data, and you only want to fill some of the memory locations, then how can you do that? You can just mention the address. See, address of 0. So this is address of 0, sorry, from 0 to 7. Okay, so this is address of 0. So in this address of 0, what you want to store? You want to store 1. In the same way, in address of 3, in the address of 3, what you want to store? You want, that means you can store it individually also. Or else, for example, if you want to store it in a group, like you want to store the data like 1011 in from third to 0 to 3 memory locations, then how can you do it? You can do it by using path select. Okay, if you see here, this is my particular register, which is address, which is named as address, and it is having some 32 bits. Okay, 0 to 32 bits. Okay, in this 0 to 32 bits, from 23 to 16. Okay, like from 23 to 16th bit. Okay, I want to store the value like 6 3. Okay, so this is 6. Okay, sorry, this is 6 means, okay, here is also what? Okay, 6 and 3. Okay, so this is how basically the thing is there. Okay, in this way, when you are mentioning it, then it is allocated in this way. This is 6 and this is 3. Okay, clear? So this is verilog part select. So if you see here, let us see some more examples. YS 7 down to 0 A. So that means it is 8 bit. Okay, in this I want to send some data within, like A 7 down to 0 means it is allocated like this. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So it is from A of 0 to A of 7. Okay, in this A of 0 to A of 7, I want to send my data from 2 to, that means 1, 2. So in these three memory locations, I want to send some data. So you can just part select these three and you can send your data like 3 tick B 0, 0, 0. If you are going doing like this, then the data will be transferred into this particular three memory locations. Okay, similarly 31. So what is this means? For example, if you want to send like some 32-bit data to bus A, as well as some 32-bit data to bus B. Okay, so instead of writing these two, in order to avoid these two lines, what you can do is you can just avoid all this and you can just put comma and you can write here itself. That means since both are having same memory locations width, so you can just directly mention it like this instead of writing it like this. Got it? So this is about verilog, bit selects and path selects. Okay, so this is all for today. Like this is about verilog, bit selects and path selects. Okay, in the next class we'll be talking about what are verilog arrays, which is really important in verilog as well as in system verilog and UEM also. So don't miss that particular class. Okay, if you like my explanation and if you are interested in this course, you can continue watching my classes. And also, if you like this channel, please consider subscribing and also share to your friends about this channel. Thank you.